So I'm back with another product review. This is a industrial slash lab power supply from Xtronic. It is the Xtronic 6080 from the Xtronic 6000 series. Now this lab power supply can supply up to 30 volts and 5 amps. Today I will basically be talking about its features and doing some demos on how this could be useful to, for example, engineers, hobbyists, mechanics, a whole variety of people. I really love this station. I picked it up for about 80 bucks and so far it's been proven its worth. Alright guys, so I hope you guys enjoy this video. If you like it, please like, comment, or subscribe. Okay, so for starters, this unit comes with the unit itself. You get 8 of these power adapters. Now this is what really made it worth it for me. Even though the power supply itself is very good, this just takes it to the next level because it makes testing so many items really easy. And to use these, it comes with this cord, so adapter where all these different adapters can plug on, and the other side of the lead has wires where you can either just screw them onto the station, or you could just clip them to the alligator clips. And that's the next thing that comes with it, is these alligator clips. It has the banana plugs on one side and the alligator clips on the other side. So why don't we just kind of move the station around and see what it looks like. So from the front has the power button. It has the negative and positive leads, and it actually has a direct connection earth ground, which is also very useful for me. It has a current adjustment, so you could use fine or coarse, voltage adjustment, and the current if you want to see it in milliamps or amps. If you look on the side, so there's ventilation holes on both sides of the station, and then on the back it has a plug for 120 volts AC, and it has a big hole for the fan. It has a very good fan inside. Okay guys, so we're about to turn on the unit. Just be warned that my camera is not very good with LED screens, so it might be flickering on the video, but here you go. So right now we're at 0 volts and 0 amps. Basically this knob, you can crank up the voltage. So right now I'm at 27.2 volts with just the coarse adjustment, and then when you get the fine adjustment in, you can go all the way up to 30.1, and it goes on its lowest, it will go down to actually 0 volts, which is real nice because a lot of stations don't go that low. And then you can actually adjust the current. So basically, if the constant voltage the change voltage LEDs on, that means you can adjust the voltage, and basically the on this side, this basically turns into a current drop meter or amp meter. And then when you actually turn the current knob all the way back, once you've set the voltage you need, then you can actually adjust the current if you have something hooked onto it, which I'll show you in a little bit. But basically then you'll see the voltage on load. So what's real nice is not only is this a lab power supply, but it's basically like a multimeter and a current meter, depending on how you're using it. Okay, so now we will kind of start going into the demonstrations a bit, and throughout I'll talk about some technical stuff. But I hope you guys enjoy this video once again. Alright guys, so here I have a white ultra bright LED, and as you guys know, so to ensure you don't burn out LED, you have to have the right current limiting resistor in series, and to find out which value to use, you have to know your supply voltage and then do the calculations. Well, that can be a hassle when you're just trying to go through your old parts bin and see if something works or not. With this station, it's not a problem anymore. So basically, right now I'm in the mode to adjust the voltage. So since I know this LED needs 3.2 volts, I set this to 3.2. It set to 3, and then I can use the coarse adjustment to set it to exactly 3.2. And then we're gonna take the current knob and we're gonna turn it all the way back, and it goes into current adjustment mode. And then you'll notice this drops to 0 because there's no current going through, but your voltage is set at 3.2. Then we can just hook on the LED, and then I'm gonna start turning up the current. So right now we're at 20 milliamps, which is a good current for this LED, and the LED is lit. And then what you'll notice is once as you're adjusting the current, once the current goes enough that you can maintain your set voltage, you'll go back to voltage mode to adjust the voltage. So you can set the voltage higher, and then you can make the current higher. If you wanted to have some fun, you could crank up the volts and blow up the LED like that, but I don't recommend you do that. Okay, so you guys may be wondering how this unit is useful to a mechanic. Well, in modern cars, there's all the sensors require certain voltages. For example, most of the sensors use 5 volts, and then there's vacuum switching valves and such that require 12 volts. Well, if you watch like online repair videos, most mechanics will use a 9-volt battery to try to test these items, but a lot of times that is not enough juice. So for a mechanic, this would be a good tool to have. So right now I have 12 volts set, and I have this vacuum switching valve I want to test. Just hook up the leads. Polarity doesn't matter since it's just a solenoid, and you can hear that clicking when I'm activating the solenoid. And so I have the lead hooked up, and this is even showing me that this solenoid uses 390 milliamps when it's hooked up. So not only is it allowing me to test the unit, it's also telling me how much current this item is drawing. That way I can know if it's drawing too much current or if it's normal current draw. Okay, this time I'm back with the relay. Now these are used in cars, these are used on circuit boards. They're pretty much used to use a small load to switch a bigger load. So now with this unit we can test a relay as well. Normally in a car the relays are 12 volts, and the way you test it is you hook up both leads to each coil end. So on this one, the pin 86 and 85 are the coil, and I have it set to 12 volts. When I hook it on, you hear the relay click, and you can see it's drawing 170 milliamps right here. So this is another tip for mechanics or do-it-yourselfers at home. You can easily test relays with this unit. Now while we're on the subject of relays, there's a lot of other stuff you can test. For example, let's say you didn't know how much minimum current it took to switch this relay. Well, you'd set it to 12 volts. You would go into current adjustment mode. You would have the relay hooked up, and then you would slowly adjust the current until the relay turned on. So we'll use coarse adjustment. So you can hear the click. So at a minimum, about 780 milliamps are required to switch on this relay. This is very useful because especially if you have junk parts laying around, you don't know what current, you don't always know how much current it's going to take to switch that relay. Well, now you know, 80 milliamps. The other example would be, what if you didn't know the voltage it was going to switch to take to switch the relay? Well, you just go into voltage changing mode, because a lot of times on circuit board relays they have 5-volt relays, 6-volt relays, 12-volt relays, so you don't know which exact voltage it's going to take. So you can pretty much just start adjusting the voltage, and this one will actually switch at a minimum of 6.9 volts. So as you guys can, if you listen carefully, there you go. Okay, now here's one of my most favorite features about this unit. So let's say I'm a computer repair shop, or I'm just trying to test my own laptop. So I have this laptop that doesn't have the LCD, but I just hook it up to an external monitor, and here's your charging port. Well, what if you're trying to figure out if a customer's charger is bad or if the charging port itself is bad? Well, guess what? This is where these things come in. So you pretty much have to find the right adapter to fit that. So it's not this one, it's probably the white one. Once you find the adapter, you just plug in the adapter, and then I have the plug already plugged in, so that just plugs into the adapter itself. And as you guys probably know, most laptop chargers supply about 19 volts, so we'll set this to 19 point. So we're at about, the reason what's happening is due to current draw and voltage drop, the voltage is dropping and I can't set any higher. So once I hit this button, I can actually go into amp mode. Now I'm at 27 volts because it's letting in more current. So I'm at 19.1 volts and it's charging the laptop. It's running about 1.47 amps. And as you can see, the charging light's on. So what this is telling me is nothing's wrong with the, it's probably the charger that's bad. It's nothing's wrong with the unit itself. And once I flick the laptop on, it's drawing about 3 amps. So I can actually power the laptop directly with this unit. As you can see, the laptop's turned on and it's drawing 3 amps. Now this is true for any unit. It doesn't have to be a computer. It could be like a router, modem, because a lot of times the unit will be good and the voltage will test good, but under load the voltage is not, there's not enough current to make the unit work properly. With this you can test everything. So here's another quick example. This is pretty much a vehicle security system with the remotes, and pretty much the point I'm trying to make here is you could pretty much anything that uses between 0 and 12 volts could be, 0 and 30 volts could be used and tested with this unit. For example, I had this car alarm unit hooked up, and when I press the lock button, you can hear the relays clicking and you can see the current draw jump for a moment. So pretty much the possibilities are limitless. I could stay here doing videos all day of what this unit can do, but the whole point is anything that uses between up to 5 amps up to 30 volts can be used and tested with this unit. Okay, so this demonstration is just gonna show, what if you're not an engineer or a hobbyist in electronics or anything? How could this be useful to you? Well, a lot of things in our life require batteries and they tend to die. We're not always going to have a replacement on hand. For example, my car alarm remote uses a AAA 1.5 volt battery. Well, I can just set this to 1.5 volts in case I want to test if my remote's good or not, or I need to urgently disarm my car alarm. Well, here I have power going to the remote, the same amount that would be going from the AAA battery. Let me just hook these leads up properly. Okay, as you can see, my remote powers up and I can see it's drawing 90 milliamps when it's first booting up. So yeah, you don't have to be a hobbyist or an engineer or a mechanic to make use of this unit. Okay, so I'm sure some of you guys want to see how accurate the voltage is. Well, so right here I have 4.1 volts set, and on my Mastech multimeter, which is fairly accurate, it's showing 4.15, which is pretty reasonable because this can only show voltage to 2 digits, and it's pretty much spot on. And here it is hooked up to my multimeter, as you guys can see. So overall, I've been using this for many weeks now, and my overall impression is that the unit is pretty accurate. The amp, it does supply the amperage and voltage it is claimed to be rated at. Overall, it's a very solid unit. It's not a cheap knockoff. As you can see, it's pretty heavy. It's actually 11 pounds. And then some technical specifications, I would say. So it can work from basically -10 Celsius to up to 40 degrees Celsius. Relative humidity is less than 90%. It's pretty much standard stuff. The voltage stability is less than or equal to 0.01% plus 2 millivolts, and same load stability is the same as well. So I mean, everything is pretty accurate. It's a pretty good unit overall. I would highly recommend it, and it's pretty affordable. Also, recovery time is less than or equal to 100 microseconds as well. And this unit does come with this gooseneck lamp that's worth about $40. So yeah. Okay guys, so just some final one final demonstration, and then we'll just kind of wrap up and I'll tell you what I think about this station overall. So one thing I mentioned earlier was it has this direct connection to ground. So basically that's useful in many ways. First of all, there's some circuits, like some radio circuits, that do require direct connection to ground. So this way you just plug into here. You're not dealing directly with the 120 volt socket, you know. You're not trying to stick a wire in there to get an earth ground connection when you're on the second story of your room or something, you know. And the other benefits are, as you guys probably know, static electricity kills electronic devices. Basically, you can just plug a lead in here, and then right before you're about to work on a computer or something, just touch that wire and you'll be discharged. Or on eBay and stuff, you could buy those anti-static wristbands. You could just plug that into here, and this is already going to be on your bench, so you don't have to do anything special, and you'll be discharged all the time. So overall, I had one complaint about this unit. Only one complaint. Everything else, I think they designed a pretty solid unit. So on the leads, the positive lead has pretty good tension, but the negative lead, it seems like the spring's weak or something. It easily slips off, you know, it doesn't close all the way. But I mean, that's not a big deal. Alligator clips are pretty cheap, and I'm sure the seller will easily fix that problem. But I mean, that's like the only negative thing I can find. So overall, I mean, all these extras really make it worth it. Considering this unit is only $80, it goes up to 30 volts and 5 amps. And I'm sure you guys can already see it's not a cheap knockoff. You know, it's 11 pounds. It's Xtronic is an American-based company. They have a repair center in Lincoln, Nebraska. And then if you I already showed you guys, it has a pretty good fan. I've taken it apart. It has a very solid heatsink in there, so this unit's not going to be dying anytime soon due to heat problems. And the fan's very quiet, if I haven't mentioned that already. You don't hear the fan until you're drawing a large amount of current through, and it needs to cool down real quick. So I mean, overall, I've been looking for lab power supply for many years. Before I didn't have the money. As I'm getting more and more work, I'm getting deeper into electronics. I couldn't live without one of these things. But I mean, for this price, I've been seeing units that only deliver 2 amps, you know. And the best part of all, remember, normally when you're trying to work with circuits or test something or power something, you have to use these adapters, and they can't provide that much current. But it's a hassle to have one for all the different voltages. This has made my life so much easier. I just have one unit. I can have all the voltage and current I could possibly need on the bench. I could test anything, could power anything, circuits all the way to solenoids, motors, air compressors for cars. So even if you're a beginner, I would highly recommend trying to invest in one of these, so you don't have to deal with all the frustrations that everyone else has to. And once you get advanced, you'll definitely be using this every day. I hope you guys found this video useful. If you guys have any questions, just let me know. I can answer them about this unit. And I'm definitely an Xtronic fan now, just because they always have really solid products. Their customer service is awesome, and you can see that by their 5,000 plus ratings on eBay, and all of them are positive. I don't even think there's any negative reviews on eBay for them. And I mean, they have excellent prices. if there's anything wrong, they instantly try to fix it for you. I mean, what else would you expect from a company? So I would highly recommend checking this station out. Hit me up if there's any questions, and please like, rate, comment, or subscribe. Thank you.